Well, this is my presentation on predicting wine scores through machine learning. Uh, this is for the final assignment of the IBM machine learning course. Well, this is me. I'm Harm Molenaar, and I enrolled into this course by suggestion of my employer, which is Performation in the Netherlands. And during this course, I learned quite a lot, more than at my job, really. And this will be a great addition to my skill set, especially machine learning and neural networks. Yeah, are really going to help out. So the first part is going to be for the stakeholders. The second part will be for my fellow data scientists. A short explanation of the choices I made and why I made them. So what does it do? The goal is to predict wine quality perception based on several characteristics. These include the wine, the price, the country, and weather data, which is related to the country. So that comes from a separate data set. And how I approached it is through a neural network, which takes the input data and tries to create a prediction out of it. In the end, price seems to be the most important predictor for wine quality perception. It predicts price quite poorly if you want to know it predicts the quality perception, which is rated in points on a scale from 0 to 100. It predicts that quite poorly, actually. But you don't need an exact prediction, you need an approximate prediction. Is actually all right for wine, I think. So for that purpose, it's good. The most important factor is price. That's kind of unfortunate because it would be great if you could just buy wine from Chile and it would just always be good. But we don't live in a fantasy world, so price is still the most important factor. All right, so now for my fellow data scientists, the part for the stakeholders ends here. Some choices are made during building the neural network. The first step was one-hot encoding. That's because I have a lot of information which is based on country, and the country names needed to be of the country of making the grapes, of producing the grapes, needed to be one-hot encoded. Obviously, because the neural network cannot work with names. The price dimension is put in a logarithmic scale. Why? Because the price of wine differs hugely. There's wine of $2, there's wine of $2,000, and if you put that on one scale, then $100 wine seems low because there are such extreme cases, but $100 wine is actually pretty expensive already. So when I put everything on a logarithmic scale, the tiny differences in cheaper wines also became much more visible, and expensive is just really expensive. So yeah, a big improvement. The min-max scaling, also for the price dimension, really worked out. The one-hot encoded values just stay the same, because that's just 1 and 0. And for the points column, it really worked out, because points is a rating done by experts, but it was done on a range from 0 to 100, but all the ratings were from 80 to 100. So the first 80 or 79 points were not used. I don't know why they have a scale of 100 points and only use 20% of it, but that's just wine experts, I guess. But yeah, the min-max scaler just throws out the first part that is not used and spreads it out over 0 to 1. And yeah, this way the rating actually can be used. So for a model, I used a neural network. and some feedback evaluation. I would have loved to automate the evaluation because I have no experience before this with neural networks, and I don't know what good values are or what good types of layers are, so it really came down to trial and error, and automating it would have been like doing a grid search on all the variables that I wanted to switch up would have been really nice, but I was working in a Jupyter notebook, and I couldn't do it like in a more object-oriented way, and because I had to stay in a Jupyter notebook, it would become a really big mess if I made it any larger. So that's why I just did some trial and error, just tried separate values and just run again, run again, run again, and keep track of what worked and what didn't. So this is the model I ended up with. 3 layers with 1 output layer because there's only one value I want to predict, points, and the rest is pretty standard because, well, I didn't see big improvements. The big improvements really from altering the neural network. The big improvements really came from changing up the data. Like I said, the logarithmic scale made a big improvement, and the also, for example, dividing the point scores like into categories, which are less than 100 categories, which you automatically get with min-max scaling. Yeah, that worked out. When right now, if you can choose from 100 points. So there's like 100 classes the neural network can put wine in, because so if it's random, then it has a 99% chance to be wrong. If I decrease it to like 10 options, then the model performed way better, of course, which makes sense. That is also why I think the model only got a 3% accuracy, because, well, first, there's too many classes, and well, in terms of taste, wine is like bad, good, medium, alright, pretty bad, but there's not 100 versions of this quality rating. We just want to know if a wine is good or not. So having 100 different classes is kind of useless. So that's also, and when I reduced it to 10, then the performance went way up. That's actually all of it. Oh, sorry, the epochs. I chose for 80 epochs because I could. That's one part of it, because I had the time. 150 megabytes for the whole data set, so it's not too much, and runs pretty quickly. It converges to an answer like quite fast, like after 15, 20, but I had a spare computing power, so why not 80? So thank you for your attention. You can email me at h.molena@webmail.com, and I look forward to any of your questions. Well, thank you for your attention.